Hello, everyone. Thank you for tuning in to this episode of the Amazic podcast. I'm Twain Taylor, editor at Amazic, and we hope you are enjoying the conversations we bring you. If you like this, go check out all the things that we've been talking about over the past few years. You'll find them all at amazic.com. That's AMAZIC.com. You can also head over to our YouTube channel, find us on Spotify, wherever you listen to podcasts. So do stay tuned into all of our episodes. I'm excited about today because I get to talk about things we have talked about quite a bit, but I think we have a product that's taking a different approach with things that we are kind of familiar with, concepts that we are familiar with. We're going to be talking about runtime security today. And we have spoken about different concepts related to cloud native security, Kubernetes security, API security, and different other vendors solving for different use cases within the security landscape. And of course, it's a huge ecosystem when you talk about security. I have with me today Rahul Jadhav, who is the co-founder and CTO at Accunox. That's ACCUKNOX, Accunox. Rahul, it's great to have you with us. Thanks for joining, buddy. How are you doing?
Pleasure to be here, and thank you for having me here, Twen. By the way, I've seen some of your past episodes, so really love it. Looking forward for this discussion. Yeah.
All right, awesome. Yeah, great to hear. Yeah, I'm really excited to be talking to you as well because it's very rare to speak to a fellow Indian co-founder, but we've had a couple of them recently, especially. So I'm really excited to see that there's so much action happening in India right now in this particular space, Kubernetes and cloud native. So
Indeed.
really excited about that.
Same here, same here. Great to talk to you and the community here.
Yeah, so to get us started, I'd like to go back to a while back when what led you to creating this open source project that we're going to talk about today called KubeArmor,
Yeah.
and was your startup that's built on top of it, Accunox.
Yeah.
Go back and tell me about just your background, what you've done, what led you to zeroing in on this as the problem you want to solve, and then the moment that actually led to you creating KubeArmor and founding Accunox.
Yeah. So there's an interesting story behind it. Actually, by way of background, I've been a developer for past 25 years. Been working in the systems aspect, been part of Linux kernel development as well. I was primarily working on the networks and transport optimization space. Multi-part towards the end, I was working primarily on the multi-part TCP transports as well as quick transport. Kernel space was always kernel spaces was always an area of interest for me, as well as a lot of development that I did was in kernel space before. One of the things that I was working before starting Accunox was using eBPF for data center transport optimization. So I had some background in eBPF and some of these emerging concepts. I know I was really excited about it. And in 2020, we came across, we were working with this one of our customers. I mean, back then they were not a customer. It was kind of a mutual friend, design partner kind of thing. And they said, we have this particular problem. Most of the existing solutions out there are kind of observability solutions. What can you do? And we said in terms of eBPF, you can do so and so. And at the same time, during the same era, right, like you have Cilium emerging, during 2020, 2019, that's when Cilium started to actually start showing up on the landscape. And we said, Cilium is doing this great work in the context of network security. Can we make use of eBPF and eBPF related security in the context of systems aspect as well as networks aspect? But one thing we thought that was missing there, which Cilium already was doing in the context of networks, but almost none of the other engine was doing it, was inline mitigation or preemptive mitigation. Most of the other solutions were kind of detect and response solutions where you have an observability engine in place, you emit the events, you send the events, you disseminate the events to a control plane where someone is watching on those events and says, oh, this is a malicious action. Let me take a responsive action. It could be in the form of killing the process or killing the process or quarantining the node or deleting the pod and things like that. Like, what we fundamentally said is, if there is a ransomware attacker, the ransomware attacker might have already done their job by the time you take this responsive action from the control plane. Then the second important problem is what happens if the control plane is not reachable at that particular point in time? What do you do in that case? So all that led for us to think that, is it possible for us to actually envisage an engine which can do inline mitigations from the system's perspective? When I say systems perspective, what I mean is from the process behavior, from the file system behavior, even from the network behavior, but from the process orientation. Is this process allowed to fork this network connection, start this network connection? Is this process allowed to fork this another process? Is this process allowed to access this sensitive asset? If you look at most of the attack surfaces out there, the attack most of the attacks are manifested during runtime, be it data exfiltration, remote command injections, crypto mining attacks, malwares, and all of these are actually manifested. They want to make use of your resources or make off your, steal your resources or just for fun, but they want to attack your runtime systems. So that's where we started. In 2020, we said, this is an area, and obviously there were other great engines out there. Like Falco is a beautiful engine out there which can do an amazing observability job. You can put in all sorts of rules, but what we wanted to differentiate on was, can you actually say, not just like, if this process spec matches, then send me an event. Rather than that, can you say, I want to allow these set of processes to execute and deny everything else, or I want to allow only this particular sensitive asset to be accessed by this particular process and deny everything else. That kind of model was not there. And the reason why it was important was because of the security principles. You have all sorts of talk tower attacks, like time to check, time to use attacks that gets manifested if you don't have a security engine which can do preemptive mitigation. That was the thought process. I even remember right now we had this conference call with Suchakra Sharma, Jehun Nam. He's from South Korea. Three of us were discussing, what can we do? And we said, if we have to do it rightly, we have to make use of the right primitives. And there are only so many primitives. SecComp is one, Linux security modules is another, and we discussed pros and cons about each of them. We said that if you have to do it right, we have to use Linux security modules. That's where everything started. That's where the ball started rolling. And we said, let's do a POC. And the POC was successful in the sense that we could see its usefulness. It's not like we were doing it for the first time. LSMs have been there for past couple of decades. AppArmor SLX, people have been using it for past couple of decades. But in the context of containerized workloads and Kubernetes workloads, it's become extremely difficult to actually operationalize this concept. That's where we said, can we simplify this user pain? Can we actually reduce some of the frictions for adopting this great technologies? And that was the thought process to begin with.
And that was how KubeArmor was born. You made some interesting points there about the current available tooling focuses a lot on observability, and you wanted to build something that blocks and allows actions based on criteria. Really interesting thought there, and seems like that's the core idea behind KubeArmor.
That's right.
Yeah, and I was wanting to just dig into a bit about that. And so it's basically policies, that kind of act as a gatekeeper, allowing, controlling what is allowed and not allowed.
Correct.
Uh, how is that similar or different from, let's say, OPA, right? Open Policy Agent, what it does, or any of the other authorization tools that also kind of talk about similar things. Are there differences or similarities?
Yeah, I think this is a great question in terms of the point at which the enforcement is done. When it comes to OPA, Kyverno, KubeWarden, these are admission time policies. When you say, when my workload is getting deployed, if that workload has so and so, if someone is deploying privileged container, do not allow it. So it's an admission time. What we are saying is, or what the aim for most of the runtime security engine is, once the workloads are actually deployed, they start executing. A lot of these workloads have known vulnerabilities. Like, it's impossible to patch all the vulnerabilities within a given workload. So you are always going to end up in a situation where you have known vulnerabilities in your target environments. And then there are unknown unknowns in the form of zero-day attacks. So it becomes extremely important to secure runtime environments. And this is where we said, admission controller policies alone cannot be enough. They are important ones, but not good enough. Yeah.
Mhm. Um, yeah, yeah. Okay, really interesting. So what you're saying is that tools like OPA and Kivono, they don't really have any effect on production itself.
Right. Right.
Okay.
They have to
Oh,
orchestrate policies which can then come into effect in production. For example, OPA and Kubernetes can say when a new namespace is created, automatically apply these network policies. But network policies are the one which are actually getting deployed, right? So the admission controller policies are different from runtime
okay.
policies.
So essentially, do you get an outside-in view of the your attack surface? Is that how KubeArmor is built to kind of see and protect things from the outside in?
Yeah. So in general, our hypothesis was this, like, Kubernetes workloads or container images as compared to host-based execution, systemd mode of execution. You're doing some atomic work within your containers. But the way in which the containers are built, right? Like you actually have base image, or your container itself might have a vulnerability which might allow you to do remote command injection. So you have an atomic image, atomic workload. How is it possible for us to say, you know, only allow certain actions to be allowed within that particular container? It's much more easier to actually model an application behavior of a containerized image than something at the host level where it is extremely noisy. You have so many systemd processes that are running, so many host processes are running. But at the container level, it's much easier. So that's what we said. In general, it is much easier for us to observe and model the behavior. Based on that, create a systems policy and networks policy as well at the same time. KubeArmor helps you with that as well. You get a network view as well. And then, basically, but you're right, it gives you an outside in view where, you try to connect from outside and check what are the things that the application is doing, model the application behavior, and out comes a policy.
Mhm, mhm. And like you said, two things that kind of I found interesting from your responses, like you said earlier. One is that when you try to, respond, to kill certain nodes or, do some remedial action,
Yeah.
if it's a ransomware attack, the attacker has already done that.
Yes.
And yeah, there was one thing as well, that other thing that you mentioned that I kind of forgot. But yeah, I was just wanting to dig in to that a bit more and ask, once an attack has happened, uh, what are some ways that KubeArmor helps when there's already an attack that you found out about?
Yeah. So uh, let me give an example. Let's instantiate, what this is one of the popular use case with KubeArmor. A lot of deployments make use of on-prem secrets manager like Vault, right? Like, and this Vault creates some sensitive assets. All your secrets are part of this vault. So if an attacker gets hold of this vault and then encrypts the volume bound point, your organization is essentially at a complete standstill, because nothing else, everything depends upon the secrets to do internal authentication and all those stuff. So as an attacker, you can actually, and you don't have to actually find a vulnerability in Vault. If you are able to find a vulnerability in any other microservice within the same Kubernetes cluster and then do a lateral movement to Vault, you should still be able to inject binaries within the Vault. And then within the Vault itself, the volume mount point is mounted within the Vault where all the secrets are stored. Basically, this is, with this, the ransomware attacker, it takes few milliseconds for the ransomware attacker to actually either delete the sensitive assets or re-encrypt the sensitive assets. So that's where we said, a remedial action is useless in this case, because like you said, deleting the pod or quarantining the node, or it's a PVC, right? Like, it's a persistent volume that is mounted inside the pod. So deleting the pod is not going to help you. And even if it helps you kill the process, the malicious process, by the time you go and kill the malicious process, it's already too late. The other point is attackers are actually have a land and expand strategy, right? Like, they want to always find a vulnerable workload and then expand to the areas of interest, workloads of interest. So they are looking for tactics where they can actually bring in a scanning tool. They use package management tools, network scanning tools to execute things. And the best thing is all of these are actually captured as part of MITRE attack framework, and these attack frameworks tell you what are the detection rules you could make use of, what are the mitigation rules you could make use of in the context. What I'm trying to say is these detection and mitigation rules, you have to make sure that you apply properly. You can't say detect and respond and say it's a mitigation rule. So when you say mitigation rule, it has to actually stop in the first place. For example, one of the mitigation rule for for man-in-the-middle attack from MITRE is do not allow an attacker to override the root certificates folder. It's a very simple mitigation rule where it says you have a /etc folder where all the certs are kept. Do not allow. There is no reason why anyone should be upgrading those root certs at runtime during the container lifetime. Why are you allowing it to modify it? Keep it in read-only mode. Uh, it's a simple mitigation point, but by the time you take a mitigation action, or a remedial action using a detect and respond model, the damage is already done. So you need someone which can stop the update to happen in the first place. That's the primary security model that KubeArmor tries to instantiate. And don't get me wrong, it was not like we tried to check whether we can actually integrate this concept in the existing tooling. We couldn't do that because it requires a fundamental change in the design of the security engine. And that's where we said, oh, we can't work with existing system because either it will require a complete rehaul of the architecture itself, or we build another tool. And that's where we started the ball rolling. Otherwise we could have actually gone with some existing tooling and built on top of it. In fact, for network security, we built a lot. We have made a lot of contributions to Cilium itself. We didn't start a new project by ourselves. There was no point in doing that. Cilium was doing a great job, and we had some incremental updates. But the same was not true in the context of KubeArmor, so we had to build another one.
Mhm, mhm.
And that's
Interesting.
precisely when we approached CNCF as well. So in CNCF, there was already a project which was having a similar mindset, which is called as a Security Profiles Operator (SPO).
Mhm,
And that wanted to do something similar, but their model was slightly different. And we said, CNCF team, the technical oversight committee really provided us with a great feedback and said, why don't you go ahead? We'll be happy to have you as part of Sandbox. And that changed the course actually for us.
Right. So right now it's in sandbox.
Yes, it's still in Sandbox. We have applied for incubation, but these days incubation takes a longer time.
Mhm, mhm. Oh, nice. What about other challenges? So we spoke about external threats. Does KubeArmor help in any way with internal ones? Because I think those are actually the more harder ones to catch and spot,
Yes,
right?
yes, yes. And we see all this happening all the time, right? Like, DevOps folks or internal folks who have direct exec access into the target workloads or SSH access onto the target worker nodes. These folks can do tremendous damage. But as an organization, if you say, you have GitOps in place and you say this policy cannot be removed because of GitOps, because if someone has to actually raise a pull request and make changes in the Git repository itself. So you can have KubeArmor policy which completely disables exec, or they can say diagnostic mode can be enabled only if someone raises a pull request and the pull request get merged, and then the policy is applied to enable diagnostic tooling. All these possibilities exist. But yes, that is absolutely a major problem today, where internal folks might do data exfiltration or do command injection or try to execute some sort of malware by themselves. That is completely a possibility.
Mhm, mhm. All right, all right. Yeah, really interesting. So yeah, so we discussed the challenge in depth and kind of even touched on KubeArmor's approach itself to runtime security. And I was wondering if you could, in a minute, probably give us a demo or
Yeah,
share something about what it looks like in action. Yeah, and yeah, that'll be a great next step for us to really get to see
absolutely.
what KubeArmor actually looks like.
Absolutely. I would be happy to show you. Before that, maybe I'll explain few more design internals. Where is it that we are differentiated? This is the kubearmor.io page, and you'll see some of the points mentioned here, like inline or preemptive remediation, and some of these innovations are because of certain uh, engines that we are making use of. You'll see time and again a term called as BPF LSM being made use of in the context of kubearmor. The BPF
Mhm.
LSM is the one is a technique that was upstreamed in kernel version 5.8 and above. This allows the kernel to actually inject eBPF bytecode at LSM hooks, which means you can do enforcement, not just observability, but
Mhm.
enforcement as well. This is something that KubeArmor really, really loves to use. What I mean by that is, if there is this LSM exists, then this is given the priority. But in general, let me show you one use case where what I have is actually a 5G workload, where there are a lot of sensitive assets within the 5G workload. There is something called as, let me show you. So I have this 5GC telco workload. This is essentially a 5G core deployment where you have all these different workloads. NRF, BSF, PCF, UDM. UDR is Unified Data Repository. This contains sensitive subscriber data, which is kept, such as long-term subscription keys. What we are able to do with KubeArmor is currently, let me show you a sample policy. So this is a sample KubeArmor policy. What it says is only from the process perspective, only allow this set of processes to execute. And here we have only specified one. This is the entry point for that particular container image. We are saying that from the network perspective, only allow this particular process to use raw TCP and UDP network primitives, and no other process will be allowed to use those primitives. There is an open 5GS volume mount point. This is from the files perspective. There is an open 5GS volume mount point. Only allow this particular process to access that volume mount point, and everything else will be everyone else that access to that mount point will be disabled. What essentially this policy is doing is it's modeling the 5G workload, saying UDR is supposed to execute only this. And the best part is that KubeArmor gives you visibility into the workloads as well. So you get network as well as process visibility. Here you can see what are the processes that are executing within the UDR. And all this is coming from KubeArmor. I'm using a user interface here, but you can use all sorts of CLI toolings as well to get this information. Both the process visibility as well as the network visibility you'll be able to get, all the other services that it is connecting and the thing. So going back to the policy, we have a policy which says zero trust policy, allow only specific things. Currently it's inactive, which means that as an user, I should be able to exec into the pod. So this is the corresponding Kubernetes cluster. KSP stands for Kubernetes Security Policies. Currently, there are no policies deployed. Uh, this is the workload. All these are running since several days now. And let me just show you how KubeArmor pods look like. So there is a daemon set that is operating. So this is the daemon set that is operating since 44 days. And if I apply this policy, but before applying this policy, let me see if I can exec into this workload and access that sensitive asset, right? So I should be able to exec into the workload. I'm executing into the workload now, bash. Yeah, so I have executed into the workload. I should be able to see. So you see that the standard Open5GS UDRD binary daemon is running. There is the Open5GS sensitive asset here, and it has all sorts of folders. Apparently inside this, there is all sorts of subscription keys and things like that, which are managed by UDRD. Now, look, how freely I'm able to explore the environment without any limitations. I have complete execution. In fact, I can go ahead and install external packages as well. I can go ahead and update and do an apt install as well. This is extremely concerning because anyone can go into your production environment and do this kind of stuff, which is a problem. So now what we have here is a policy which says only allow specific things and deny everything else. So if I apply this policy, I'll apply this policy. So it says policy activated successfully. Since I've already executed, the bash is already running. But if I try to execute anything else, you'll see permission denied, apt permission denied. But the original binary, the UDRD binary is already executing. If I exit from this shell and try to even exec into the same shell again, even this should be denied. Yeah, you see permission denied here. And then all this denial part, right? Like this information you'll get as form of alerts. So you get detailed in the last 5 minutes, what are the events that have been coming out. So you see this container ID from this particular cluster name. This is the host name, which is the worker node. This is the namespace. This is the deployment from which this event is emitting. Bash, someone tries to execute bash, and the parent process was runc. So all this information you are able to get. They should also have somewhere apt. We try to run apt, right? Like we see apt also in the second event here running. So all this was blocked. uh, and imagine, so what we are saying essentially is, tomorrow if there is an unknown, if someone else tries to, let's say, udr binary or the application itself has a vulnerability that an attacker makes use of, or it has a misconfiguration that the attacker make use of, you can then say, the attacker can't do anything. The attacker won't be able to inject any executables. The attacker, even if somehow the injection works, the attacker won't be able to execute that executable, or that executable won't have any network permissions. That executable won't be able to access any sensitive assets. So it's multi-layer defense that you get automatically. And as you can see, it's very easy to actually model the behavior of the workload itself. It's simplistic policy if you look at it. It's not a very complicated one, and most of the policies are similar ones. I'll give you one another example of Vault, which is HashiCorp Vault hardening. It has a similar model. I gave an example of it already. So this is the policy which completely emulates the Vault behavior, where what we are saying is allow Vault binary to execute. BusyBox is allowed so as to show, allows some sort of diagnostics, but you can even remove BusyBox as well. Usually this is enabled so that we can show you some execution and attack surfaces. Then you are saying that only Vault mount point should be accessed by this particular binary. So the aim here is a very simplistic way of actually creating a policy, zero trust policy for your workload, where even if there are zero-day attacks in the future, you should be able to tackle with it, in an inline mitigation way. It's not a detect and respond model. Yes, you can use detect and respond model. There are two problems with detect and respond model. You have to ship all the kernel events to someone in the user space, and then the user space policy engine has to make a decision. By the time you make a decision, it's already late. And the other problem is the performance issue. You have to ship all the events to user space. Doing the kernel context switch is extremely costly for all of these events. So from the performance point of view, from the security point of view, it doesn't help. This is where KubeArmor changes the rules of the game.
Mhm.
Uh,
Oh, yeah, really interesting. Sounds very like on the ground and very close to reality, the kind of security implementation you have here, which is really powerful. And how do you define who can create policies, who can change policies within the organization? Where is that within the product? Which part of it?
Yeah. So within the product, so all the KubeArmor policies essentially are Kubernetes resources. So if someone uses GitOps model or admission controller, where you can sign these policies, only allow signed policies to be injected, all that sort of things can be done. Within the Equinox product itself, we have a strong RBAC where you can say only these set of users would be allowed to create policies. Only these set of users would be allowed to, you have extensible rules where in the context of cluster management, app behavior, policy creation, policy management, only certain people will be allowed to approve policies, delete policies, activate inactivate policies, ignore policies, or create policies. All of these is completely handled through RBAC in the Equinox enterprise solution. But even if you're using open source, you can make use of standard practices, because KubeArmor policies are essentially Kubernetes resources, which you can use as any other Kubernetes resource.
All right, got it. Cool. As we conclude the demo, is there anything else, any new feature that you wanted to highlight
Yeah.
within the demo?
Yeah, one of the new things that we are working on is, we are working with the Coco community, the confidential containers community, where we'll enable KubeArmor and confidential containers in the same space. So that the threat model for confidential containers is different. The threat model for KubeArmor is different, but a combination of these two things can greatly change how the security is done. You have a really solid military grade security for some of the systems that you might need. Not all of the systems might need that kind of security, but certain key components, especially in the 5G world, edge deployments, edge-based deployment. And that's another point that I would like to make. KubeArmor is not necessarily a Kubernetes native engine. It works across virtual machines, bare metals, and containerized deployments as well. But essentially, if you look at the getting started guide, it gives you an information about how to install KubeArmor in the Kubernetes environment. But here you can see it supports all sorts of workloads, containerized, virtual machines, and bare metals, as well as Kubernetes orchestrator. In fact, some of the open source enthusiasts made use of KubeArmor for securing 5G workloads. And that's where we realized that this particular use case that I just showed you, right? Like that's where we realized this use case exists, and that's
Mhm.
how we set up a demo environment and things like that.
Mhm.
There's a bunch of use cases that we can show.
Okay,
Uh,
all right. Really cool. And there's something I saw about sandboxing on your website that
yeah,
KubeArmor helps sandboxing Kubernetes apps. Did you want to touch on that a bit and explain what that
yes.
is?
Yes. So sandboxing, what does sandboxing mean? So, in general, sandboxing means, you put the application in a constrained space where the application should not be able to do anything weird. Uh, Traditionally, SLNX policies, AppArmor policies were used for sandboxing. There are multiple approaches for sandboxing. gvisor is one approach for sandboxing. It's a great approach, but the primary thing that we have seen with gvisor is it's extremely intrusive deployment in the sense that you have to change the container runtime interfaces, container runtime layer altogether, switch it with gvisor's own container runtime implementation, shim layer, and then it will add a sentry wall in between such that any application access goes through that sentry wall, basically syscall entry wall. It's too intrusive. It's too flexible. It's great in terms of flexibility, but it's too intrusive. What we said is, what is it that we can make use of for sandboxing without having the user to make any changes at the host layer, or without having the user to make changes at the container runtime interfaces level, but at the same time not compromising on the security principles of Tokta and semantic poisoning issues, right? Like those security principles we didn't want to compromise. How can you do sandboxing while keeping the security principles in mind? So we are getting a lot of traction in that space, and a lot of traction we are getting in that space one reason because AI workloads require this kind of capabilities. You might have heard of AI agents getting a lot of traction. Let me paint you a picture here. AI agents are extremely powerful. AI agents can collaboratively get things done which a single AI agent cannot do, a single AI system cannot do. But the moment the people think about putting in such kind of system in place, they are obviously worried about security because you have given complete access to your environment to these AI bots and AI agents. And how do you ensure, how do you keep, or how do you keep these agents on leash? That's where some of these sandboxing techniques come into play. If you look at TensorFlow, if you look at PyTorch, if you look at the threat model that they have defined, they say that TensorFlow essentially provides you models which are essentially programs that can then execute things and get work done for you. And these models should be treated as processes, and you need to secure these processes. That's what TensorFlows. In fact, let me quickly pull it up. It's very interesting because uh, uh, if you look at the security model, right, like TensorFlow's runtime system interprets and executes programs. TensorFlow
Mhm.
models are programs and need to be treated as such from security perspective. As a general rule, always executes untrusted models inside a sandbox. The example that is given here is a Google tool called as NSJail, and it does sandboxing process isolation at the host layer. It doesn't deal with containerized workloads or this thing. Essentially, what KubeArmor is able to do is the same level of isolation, but for containerized workloads and for Kubernetes orchestrated workloads, as well as host and virtual machine-based workloads. But systems such as Kubeflow, we are testing it on SageMaker. We have done a similar sandboxing for Jupyter notebooks, where all of this attack surface is left open for the attackers to execute. So this is another point where sandboxing makes a lot of sense.
Mhm, mhm. Wow. So securing AI workloads, that's really crucial. Very interesting. You mentioned 5G as being,
Yeah,
as one of the industries that are adopting KubeArmor. What are the other? So you mentioned even AI agents
yeah.
that the use cases are really gaining adoption. What are some of the other ones where you see there's a lot of need for something like this? The other use cases and industries?
In general, what we are seeing is almost everyone is adopting Kubernetes in some shape or form. That's one trend that we are generally seeing, like including the 5G. Projects such as Nephew are leaning towards complete Kubernetes-based automation. All the telco workloads, right from the RAN, radio access networks, are completely moving into Kubernetes-based orchestration systems, primarily because of the ease of automation, right? So uh, the same is true for AI-based solutions as well. You see SageMaker, Bedrock, Kubeflow, uh, you know, and even OpenAI. OpenAI deploys all of their engines and their training models on top of Kubernetes. In fact, they have a great article as to how did they scale to a 7,000 node cluster, and this was a KubeCon talk as well. The point is, Kubernetes is getting widely adopted in all of these environments, and we see KubeArmor as one of the contenders to strong contenders to actually make sure that the security is handled in the right way. Uh, but the trend is clear, 5G beat edge workloads. There is a project called as Open Horizon in Linux Foundation, which does edge orchestration. Thousands of edge sites. We have to deploy thousands of workloads, and these workloads might share the same resources. Kubernetes is made use of for sharing these resources. The problem is you have home automation solution and computer vision solution and another workload running in the same space, in the same tenant, in the same shared resources. If one of the workload gets compromised, then you can have a lateral movement and then almost everything gets compromised. So you have sensitive assets uh, on these edge deployments. You have multi-access edge deployments these days, which the primary reason to have those kind of deployments is to do processing faster, more at the edge. But you have all the security issues that you have to deal with. So we are seeing a lot of traction, and it's not just Aquinox who is solving that problem using KubeArmor to solve some of these issues. There are other organizations who have used KubeArmor to solve some of these issues, and they have reported back. In fact, we have a very strong adopter list on KubeArmor who have used KubeArmor for securing their own deployments.
Right. Oh, wow. Yeah, as we wind down our conversation, Rahul,
Yeah.
lastly, I want to ask what's coming up for KubeArmor, in the next 1 to 2 years? What are you most excited to be building with KubeArmor?
Yeah. So there are two things, like I said, one is we are integrating with different threat models. One is the confidential containers. We are looking at deeper integrations with confidential containers. We are also making sure of expanding expanding our coverage. And this is where a lot of open source community members are helping us. You look at KubeArmor support today, that is formally verified. It's quite high, including ARM. uh, so let me just pull up. If you look at the support metrics of KubeArmor, you see great amount of support being added for most of the Kubernetes platforms, as well as supported Linux distributions as well. So this support will keep on expanding. Apart from this, there is another work item that the community does, which is creation of policy templates for predetermined workloads. For example, I showed you for Vault, similar policies exist for 5G core workloads, ORAN-based workloads, edge-based workloads, Cassandra, MySQL, Postgres. So we have pre-canned out-of-the-box policies for all of these standard workloads. So that's effort that's continuous. And then in the future, we are also planning to integrate network policy handling through KubeArmor. Now that would be game changers, because essentially what we are saying is a CNI is in charge of network policy enforcement. But CNI does a lot of stuff. It does IPAM, IP address management, routing handling, and all the other things. What we are saying is, even if you have a basic CNI in place, your network policy enforcement can be done by KubeArmor, because KubeArmor has that visibility as to what network accesses are being made. And we have, because of the LSM hooks, we have that visibility as to we can actually stop things from happening. If there is a bind connection someone is trying to do, or there is an accept that's happening, or someone is trying to send egress packets, we can actually stop that happening at the BPF LSM hooks for two reasons: for performance reason, as well as manageability reasons. So these are some of the things that you'll see in the near future, in next 6 months to 1 year's time, that you'll see coming in Cuba.
Right, interesting. Wow, more integrations and even broadening into networking policies.
Yes,
Wow. Yeah, you should come back and talk to us whenever those things launch. It'll be cool to
love to.
continue this conversation. Before you go, Rahul, just a question to get to know you a bit. What would be your alternate career path if not for creating KubeArmor, starting up Equinox, and yeah, all the tech stuff you do?
Yeah, you won't believe I've been giving this a thought for maybe last 20 years. If not development or systems engineering, what else I would be doing, and you know, I don't know, but the profession of either teaching comes to my mind,
Mm.
where I could have been a teacher or a professor, or theoretical physics is another subject of my interest. I love some of those books. Yeah,
Mm.
The Brief History of Time is my favorite book, that I always go back and look at. But yeah, if not in IT industry, I might have been possibly a professor or teacher somewhere. I don't know if I have enough qualifications to be a professor, but at least a school teacher.
Yeah, no, you sure did explain quite a few of those concepts really clearly that you spoke about today. So yeah, I think that that's a good option.
Thank you,
Uh,
thank you.
but yeah, it's great that you're building something cool here with KubeArmor, and thanks for showing it to us today. It was really interesting to see that, and I hope our listeners and viewers as well found it interesting enough to go check it out on GitHub or on the Equinox website. And do come back again to tell us more, Rahul.
Absolute pleasure to be here. Absolutely, absolutely. Can't wait to come back here. Looking forward.
All right, that become the end of this conversation. Thanks to all of our listeners and viewers for tuning in, and we'll see you on the next one.